Okay, so what's the area formula? Come on, guys, put those MacBooks shut, please. Vast already. Jack, what's the area formula for a circle, please, Jack?
Pi r squared.
Pi r squared. Hopefully every single one of you had pi r squared in your head. Hopefully, okay? So the area formula for a circle, for a full circle, is pi r squared, where r being the radius, pi r squared. All right? We've learnt that. We've done a test on it. We've done assessment items on it. Hopefully you understand it. We've got a variety of different cylinders here, okay? The cylinder at the start is a hollow cylinder with no ends. Okay, what's an example of a hollow cylinder with no ends? What's an example in life of a hollow cylinder with no ends? A pipe, a tunnel, toilet roll, okay? You get the understanding? It's got no ends, all right? It's hollow. And you can go straight through it. For that reason, guys, there is no pi r squared formula in there. Okay? What is that 2 pi r h, Harry? What is the 2 pi r h calculating?
Like the volume.
No? Good try. It's the surface area still. We're still working on surface area. It's working out the surface area of Cheyenne. Height is there. And this is radius. Out of this shape, what is it that we are calculating? What are we calculating? Lee, I've asked you, please.
Is the ring on the outside?
Yeah, I asked for green and blue. Did I? Sorry, green and blue I meant. Sorry, Lee. Jack.
The outside ring kind of thing.
Yeah, this curved surface. Okay, it's this curved surface here. It's sort of got, yeah, a bit of a curve to it. All right, and all you need to calculate what that curved surface's area is a radius. Okay, radius across here, and the height. And so that equation there, you'll notice, bobs up in each and every one of these. 2 pi r h, 2 pi r h, 2 pi r h. You won't have to memorise that, but what I'm trying to get you to understand is that that calculates the curved surface. Okay? And so when you've got an open can, okay, tin of beetroot, you open the can up. What's another example of an open at one end and closed at another? A bucket, a cup, 44-gallon drum. Yeah? It's open at one end, but it's closed at the other. Because it's open at one end yet closed at the other, we have our area formula calculated just once. Because we're just calculating that. And what does this give us, Alex?
Height and radius.
Yeah, what does this whole calculation calculate for us?
Answer. The ring.
Jeremy?
Like the outside ring and the bottom bit.
Yeah, again, the curved surface. So, Jeremy and Alex, this gives you the curved surface. Okay? This here gives you your bottom ring, all right, or your bottom circle, all right, and you add them together. This one here is like an aluminium can. It's got both ends covered, okay? It's got both ends covered, and on this occasion, we're not calculating just 1 pi r squared, we're calculating 2 pi r squared because it's relating to one circle plus another circle. We do it twice. They're identical.
And you times all that, wouldn't you?
So 2 times the pi r squared, Jake, and then you add it to, this is, Alex, what does this calculate?
The ring around the outside.
The curved surface here, yeah? Okay, the curved surface. Alright, so maybe let's disregard the ring around the outside, let's start saying the curved surface, okay? So this is just finding the curved surface. Here you're finding the curved surface plus one area of one circle, being the bottom. And here you're calculating the area of the curved surface plus 2 areas of circles. the area for the circle formula shouldn't be foreign to you. You've used it plenty of times. Some of you didn't memorise it in your test, but others of you were able to. That's the area for the circle. Here you've got 2. Here you've got 1 of them. Here you've got none of them. So when we go to questions, they'll talk about a solid cylinder. A solid cylinder has 2 ends covered. Okay, so in this example, you can probably see it on your MacBooks, you're doing 2 pi r squared. Okay, if I can scroll down, we can just have a bit of a look about how the questions are asked. Okay, here's a classic one. Jamie is painting cylindrical tin cans which have a height of 12 centimetres and a diameter of 8 centimetres. She paints the top, the bottom and the side. So that's a full can, again, a full can. What do you notice that they do? They draw the shape. They draw what they're reading, all right, because that can become too hard just reading it and trying to pull out 2 pi RH. 2 pi RH, it looks like that. 2 pi r being 4, h being your height, and 2 pi r squared being that circle calculated, plus that circle being calculated. When you add them all together, you get about 402.12. All right? So then it says, if Jane has enough paint to cover an area of 5 square metres, how many cans is she able to paint? This is for 1 can. 5 square metres means going back up to your conversion charts. Yeah? And saying, well, 5 square metres is 50,000 square centimetres. And if you divide that by what 1 can takes, 124.34, she can paint about 124 cans. Okay? How much paint would she need? Blue, you can go on with your learning now if you like. Green, how many square centimetres of paint would she need if she was going to do 2 cans? Harry? If she was going to paint 2 cans.
804.
Yeah, good, 804. 3 cans, 1200, and so we go. So that would be the process there. So they're your top end questions. They're your more difficult questions, Green. Okay. In between there, you'll have lots of diagrams to reinforce using that formula. 2 pi RH plus sometimes nothing, sometimes pi r squared, sometimes 2 pi r squared. They're cylinders, okay? That's where you should be at. If you're not there, move it along, but also understand what you're doing. Green, is there any questions you'd like me to go through there, or can I explain it better? Holster, you okay with that?
Mm-hmm.
You think you could do that, Jeremy?
Yeah.
Yeah, okay, all right. Shuffle your cups if you need be. Okay, so to start with, I've spoken before about rotating that so that the right angle is on the ground, and that makes finding the base and the height far easier. Okay, so that becomes there, your base becomes 3 and your height becomes 4. 3 comes in there, 4 comes in there. Okay, so area equals half b times h equals half 3 times 4 equals 1.5 times 4 equals 6 centimetres squared. Alright, and as you'll acknowledge, you've got 1 here and you've got 1 there. Yeah? 12 centimetres squared. Again, stop me if I'm going too fast for you, okay? So we've done the triangles. What we've then got is a 9 by 4 centimetre rectangle.
Yeah.
9, 27, 36 centimetres squared. Alright, and that takes that out. And then over the back, we've got a 9 by 3. Alright, and that was a bit of a tricky one to throw in there straight up. Probably a lot of people have got stuck with that. That's 27 centimetres squared. What are we lacking? We're lacking the base, okay? And the base must be 9 by, we don't know. So we go into Pythagoras, and I'll do that in here. We've got a 3 by 4 would give us our c squared because we've put our I in behind here, okay? And our hypotenuse is our longest side, okay? So we have c equals c squared, 3 squared is plus
16.
yeah, good. 16 gives us c squared equals 25, and c equals the square root of 25, which I hope you might know by now, but if not,
5.
it's 5 centimetres. So now we've got this length. We can go ahead with the base.
Yep.
Alright, the base being 9 by 5. Area equals length times width. 9 by 5. 9 5s are 45 centimetres squared. We've calculated the area of each face. We now do TSA. 45 plus 27 plus 36 plus 12. 45 plus 27 plus 36 plus 12 gives us 120 centimetres squared.
That's what I got, and the answer says that it's 120, but 124.
No worries. Alright, now does that make sense, or has that gone too fast for you?
No, it makes sense.
That's alright. Yep.
I just wrote a number wrong somewhere.
Okay, so what face will we roll with? Again, if I go too fast, pull me up. Okay. What face do you want to roll with to start with?
I did top first.
The top, which is this dark purple area? Okay. So what shape is it? They're the questions we ask. What shape have we got? Therefore. Yep, therefore. Formula we would use. Need to know this stuff. Look back through your book. Area formula for a rectangle. It'll be back in the previous chapter that we're working on. Quite a way back. Okay, so that shape is a rectangle. We now know that that is length times width. Okay, what's the length of that shape?
We don't know because like the bottom is bigger than like the top.
So is this distance any further than this distance?
No.
No. Still the same. It's not tapering in. If it tapered in, it would get shorter. But if it's the same distance, looks like the same distance.
Like,
So we go 15. Comfortable with that?
yeah.
Try that? We can try it.
Yeah.
Get it wrong, who cares? We learn from our mistakes. 15 times what?
6.
6, absolutely. Got your calculator in front of you? Sorry?
90.
90. 90 centimetres squared. Done this surface here, yeah? Okay. What's another surface we should do?
I did the base.
You did the base. What's the base?
15 times.
Area equals length times width. 15 times 16. 16 being this distance, 15 being there. Yep. And that gives you a total of?
240.
240 centimetres squared. What should I do with my answers just so they're clear to me later?
Put them somewhere so you remember.
You could. Yeah, you could do that. You could do them over here.
Underline it.
You could underline them. That's the area I probably want you to go in future. But that's all right. Okay. All right. So we've done the base. Awesome. What next?
Figure out that Pythagoras is there in there. It's only got one side. That's not
Okay. What do we use Pythagoras' theorem for? What shapes? Triangles. What? I'll ask you. What shape do you have here? Again, go back through your book. Because they're the shapes we want you to know. We want you. And so once we have 195 times 2, 195 times 2 gives us 390 centimetres squared. I think that's about it. We add 390 to that. That's our total. Gives us 390 plus 240 plus 2.